folks, welcome back. I'm going to do numbers 3 and 4 in this video. And like before, if I have rational equations, what I want to do is find that LCD, multiply every term by that LCD so I can knock out the fractions. So when I look at my denominators in number 3, 6b squared, 6b, and b squared, the numbers or the coefficients I have are 6, 6, and 1. So that least common multiple would be 6. The exponents on b, or I should say the powers of b, right? We have b squared, b squared. The highest exponent I heard was a 2. So I'm going to put 6b squared for my LCD. Let's find my LCD for number 4. All right, if I look at my numbers 4, 2, and 2, 4 is that least common multiple. And I actually just have b squareds the whole way through. So my LCD is going to be 4b squared. Okay, so I'm going to multiply every fraction by 6b squared over here, every fraction by 4b squared over here. There's always going to be some canceling, and then we're going to see what's left. So here we go, 6b squared times 1 over 6b squared. And I'm going to write small because there's really not a ton of room here. 6b squared times 1 over 6b. That should be equal to 6b squared times 1 over b squared. All right, so the entire 6b squareds cancel out here. The 6's cancel, and a power of b, right? I have b squared over b. That will leave me with a b up on the numerator. The b squareds cancel here, so let's see what we have left. This left me with the number 1. This left me with just b, and this left me with 6. So ultimately, I'll just subtract 1 from both sides because I have that linear equation. I get b is equal to 5. If b is 5, I just want to double check that does not give me a domain issue, right? I don't zero out any denominators, so I'll go ahead and keep this answer. All right, same idea is going to apply over here. Let's take 4b squared to b plus 6 over 4b squared. Let's multiply 4b squared to that second fraction of 3 over 2b squared. And let's multiply 4b squared to that last fraction of b plus 4 over 2b squared. Now, keep in mind, we've got some of these numerators have binomials, right? They're protected with parentheses. So the entire 4b squareds cancel here. The b squareds cancel. And then 4 over 2 is going to leave me with 2. And 2 times 3 is ultimately going to leave me with 6. Or you can think of it as 4 times 3 in the numerator is 12. 12 divided by 2 is 6. Either way, you get 6. All right, here the b squareds are going to cancel, and I have 4 over 2, so that's going to leave me with a 2. All right, so let's go ahead and see what we got here. Here I have the b plus 6, right? Here we said 4 times 3 over 2 is 12. Oh, yeah, 4 times 3 is 12. 12 over 2 is 6, so I have another 6. That will be equal to, okay, 4 over 2 is 2 times that b plus 4. All right, and then let's go ahead and see ultimately what this simplifies to. So I'm going to have some like terms here. This will be b plus 12. Let me distribute here. We've got 2b plus 8. And I still have a linear equation. I'm going to get the b's on one side by subtracting the b over here and subtracting the 8. So I'll move the b to this side, right? And then I'm going to move the constant of 8 over here. So minus 8 minus 8. Let's see what this simplifies to. So those b's cancel. 12 minus 8 is 4, 2b minus b is b, and 8 minus 8 is 0, right, by design. So ultimately, when I look over here, I get b equaling 4. And if I just plug back in, that does not zero out any denominator. So I can keep that answer. So that is my answer for number 4. All right, thanks so much, everyone. Bye.